We've talked about how you calculate the expected return and variance or standard deviation for a portfolio. So now that you have the expected return and standard deviation for a bunch of different portfolios, how do you decide what's the best portfolio to choose? Well, you can use the concept of dominance. And let me give you an example here. Let's say we have a portfolio A, and let's say we have a portfolio B. So we have two portfolios, but are they equally good? Well, let's look at A. A has a certain level of risk and a certain expected return. B has a different level of risk, a higher level of risk, but based on how I drew it, hopefully, it has the same expected return. So A is better than B because for the same level of expected return, we get a lower level of risk. How about if I pick another security here or another portfolio and I put C up here? Let's look at C. If we were to compare A to C, we would say that C is better because, again, I've tried to draw it so that you have the same level of risk, okay? So it's moved the same distance on the x-axis, but C has a higher expected return. So C is preferred to A is preferred to B, and we have this transitive property that C should then be preferred to B, which makes sense because it has both a higher expected return and a lower level of risk. So you can start eliminating certain portfolios. And the way it works is that you want to eliminate everything that has a higher risk for the same level of return or a lower return for the same level of risk. So if we were to draw out this, let me see if I can draw one fairly neatly. We have something called the efficient frontier. And the efficient frontier is made up of all securities or all portfolios that have the highest expected return for a given level of risk or the lowest risk for a given expected return. So in this case, as I've drawn it, we would eliminate all the portfolios that are inside here. Okay, all of these, we can find something better. We can find a better one here. If we pick this one, we can find a better one here. If we had a portfolio here, we could find a portfolio here that was better, lower return. So you're trying to get as far to the northwest as you can go. Going this way is better because it means higher expected return. Going up means higher expected return, and going to the left means lower risk. So we eliminate a lot of different portfolios. Okay, there are a multitude. I mean, there's an infinite number of these. They're all different combinations. They may have the same securities, but they have different proportions. Say you had 3 securities, one might be 100% A and then 0 in B and C. One might be 80% in the first security and then 20% in the second, and different combinations. But you can eliminate many of them. You still have a lot of portfolios here, but you've been able to eliminate a large number of them. So this concept of the efficient frontier helps us to determine what's the best portfolio. Now, one thing we do, and I won't draw it here, is we can draw in indifference curves. Indifference curves will have a curve that's opposite of this. It'll go, well, okay, let me try and draw one in here. I'll tell you what, let me scroll down here and redo this. It gets a little too complicated if we have too many things on one line. And so if we have, again, the risk and the expected return, and we have this efficient frontier, you can have indifference curves. And the indifference curves would look like this. They would have probably a curvature like this, and you'd find the one that was just tangent. See if I can do that. Not very well drawn, but just tangent to the efficient frontier. You're trying to get to the highest indifference curve you can get to. So this would be I1, this would be I2. And again, there are lots of indifference curves. But that's in some ways not very interesting because everybody's going to choose a different portfolio. So let me draw one more picture. And you can see that if we introduce riskless borrowing and lending, it turns out that everybody chooses the same portfolio, which is really a neat concept in finance. That everybody, regardless of their preferences for risk and return, will choose the same portfolio. All right, so again, let me see if I can draw an efficient frontier here. And if we have a risk-free asset, we draw a line from the risk-free asset that's just tangent to the efficient frontier, and we get the optimal portfolio, which would be right here. So this is the risk-free rate. We sometimes refer to this as the capital market line. CML. So it's an interesting concept that if we introduce riskless borrowing and lending, even though there's an infinite number of portfolios and there's even an infinite number of efficient portfolios, everybody chooses the same portfolio. Someone who is, if we drew in indifference curves, and I'm not going to do that, I'll make it too complicated, make the graph too sloppy. Someone who's a conservative investor might have a tangency point here and choose to put some in the risk-free asset and some in this risky portfolio. Someone who's more aggressive might be out here. So let me just point that out. Let me write this out. Right here, if you're in this range here, you're a lender. You're someone who buys the risk-free asset. Remember, when you buy a bond, you're lending someone money and some of this risky portfolio. Someone out here is going to be a borrower. That is, they're going to buy on margin. They're going to borrow money so they can buy more of this portfolio. They're not going to put 100% of their money in this portfolio. They're going to put perhaps 120% in this portfolio by borrowing the other 20%. So, again, just to recap, scroll back up here. You have a lot of different portfolios, but some of them can be eliminated because they have too much risk for the same level of return, or they have too low a return for the same level of risk, so we throw those out. We get this efficient frontier. We can then, if there's no riskless borrowing and lending, then which portfolio you choose depends on where your indifference curve is tangent to this efficient frontier. But if we add riskless borrowing and lending, it turns out that everybody chooses the same portfolio. They choose this portfolio. Oftentimes we call it portfolio M, the market portfolio. And it's actually an argument for why everybody should buy an index mutual fund if you assume that the index is the market portfolio.